Okay, hello and welcome back to this final session of this very short course on artificial intelligence for beginners. Now, in the past few videos, we have seen what is the role of artificial intelligence, what are the applications of artificial intelligence, the history of AI, so on and so forth. Now, as I promised you in the beginning of the course itself, that we will take a sneak peek into machine learning. This course is not about machine learning, but I just wanted to give you a very brief kind of a heads up as to what machine learning is. And if you want, I am always willing to float a course on machine learning as well. I would love to know what you think, so you can put your opinion down in the chat or the comments. And yeah, so I think we can begin this session. But before we begin, I just want to give you a very small caveat that this session as well might be a bit longer than the other videos which you have seen, because there are so many things associated with machine learning, and yeah, it might take a bit more time than the usual. So let's get started, right? Now, machine learning has various aspects to it, and there are different ways in which we can actually train a machine. And as I have said it repeatedly throughout this course, that the way a machine learns something is entirely different than how a human learns it. So the first form of machine learning I'm going to talk about is supervised learning. Now, I'm going to show you the picture of an animal, and yes, I'm sure you've already guessed it, it's going to be that cute little dog again. And because we already have this perception, we have this ability to learn things just by looking at the image, we could immediately tell that this is a dog. Now, something which I want to ask you is that how many pictures of the same animal would you need to recognize it? So as adults, obviously we would say, even if you show me two dogs, I can recognize all the other dogs. But research shows that even for infants, these images range from somewhere between 20 to 25. So a normal kid would take around 15 to 20 images to make out that this is a dog, this is a cat, this is a bottle, this is a laptop, so on and so forth. Now, the purpose of supervised learning is something very similar. So what we do is we provide the machine with certain images, and each image is already labeled. Okay. So for example, I'm giving 100 images to a machine, 50 of them are of cats and 50 of them are of dogs, but I am not expecting the machine to know which is which. So I am actually going to label each image manually, saying this is a dog, this is a cat, there's a dog, there's a cat, so on and so forth, and the machine will already know that which label is what, right? But learning basically is supervised learning, to be specific, is based on understanding rather than the description itself. But this learning through images is actually based on understanding rather than the description itself. What does that mean? Basically, the machine will be provided multiple labels. So just by calling it a dog or a cat is not enough for a machine to understand what it is. We are going to have to provide the very basics, just such as this is a four-legged animal, and then we can classify it as a dog or a cat. Because if we only tell the machine that what you're seeing in the image is a four-legged animal, the machine might infer that to be any animal, and tomorrow if you show it the picture of an elephant, then even then the machine might call it a dog. So we have to be very careful on what we are providing to the machine and how the machine actually categorizes these different images. So this is the whole concept of supervised learning. What you need to remember is that the machine is provided labels beforehand and does not need to infer those labels by itself. Okay, moving on. The second concept in machine learning is unsupervised learning, and as the name suggests, we don't provide any label to the machine while providing the data. Now, what does that mean? Basically, the machine has to look for patterns in itself, and it needs to learn by itself. But a very important caveat here is that this is so this is different than data mining. Okay, data mining is absolutely jumping on the deep side of the pool, and we don't provide the machine anything. right? Just the raw data. But here we actually have certain patterns, and an algorithm is set. The machine is provided the information about those patterns, and some of the patterns the machine has to make more sense out of it. A typical example would be providing network information. So, for example, computer networks, etc. How do we want to set up a computer network? What would be the best way? How do we use minimum number of routers, etc. Can be a perfect example of unsupervised learning. The third form of learning as part of machine learning is reinforcement learning. Now, once again, by now I'm sure you have figured out that I love animals, and we are going to take another example of animals. But before that, let's try to understand what exactly reinforcement learning is. So you are the person who defines the state, you define the rules, the goals, allowed actions, and constraints. And for every right action, the machine will receive a reward. And you can actually call it more of an hit and trial method. So every time the machine does something which you want the machine to do, it's provided a reward. Every time every time the machine does not do something you wanted it to do, you can punish the machine as well. And this is quite similar to training your own pet, your dog, or any other animal. So they need to understand whether they are doing something is right or wrong. So if you've ever seen someone train a dog, or if you have a dog yourself, every time the dog does something such as sit down or shake your hand or anything for that matter, you provide them with a treat. So the dog knows that every time I do this action, I'm going to be provided with the treat. That means I'm doing something right. Similarly, if you don't want the dog to do something, some people go with the other method, which is the punishment learning. So you tie up the dog or you scold them, etc. So similarly, very similar is reinforcement learning, where the machine is provided incentives or the machine is punished for every action which you did not want the machine to perform. Now, once again, it's very important for you to understand that this is the absolute basic of machine learning. So if the machine learning paradigm was the earth, we still have not even scratched the surface or the crust. My whole objective of this video is to give you a very brief insight on what are the different methods of machine learning and how machine learning actually works in real life. So let's look at an example right here. Machine learning or AI have huge implications in the medical industry. And the question which I'm asking on the screen right now is, can a person die of lung failure? Obviously, the question's answer is yes. Multiple individuals throughout the globe unfortunately die due to lung failure. Now, if we are able to provide this information and history related to lung diseases, so the prior patients which have been to the hospital, the ones who survived, the ones who did not survive, their different stages of lung cancer, for example, and related lung diseases, if we are able to collate all that information and provide it to a machine, then there is quite a good possibility to get more accurate answers through a machine rather than a doctor. And actually, this is not just a myth, this is actually in practice right now. And what we have seen is that machines, especially in the medical sector, have been able to provide accuracy up to 80 to 90% in prognosis or diagnosis in the initial stages, compared to a junior doctor who were in the range of 50 to 60%. So we are already seeing unprecedented numbers in the range of 85 to 90% accuracy, which has not been seen before in the medical industry. And once again, we are literally just scratching the surface right now, and there's a long way to go when it comes to AI in medical industry. Now we have spoken about the three different forms of machine learning. I just want to run through the three different forms of data sets as well. So tomorrow, if you want to train yourself in machine learning, if you want to do a hands-on training in machine learning, you need to understand the importance of these three data sets. So the first one is a training data set, the second one is a validation data set, and the third one is a testing data set. Now, once again, where do these come from? It's basically the single data set or the single data file which you receive, and you as a programmer has to divide these data sets into training, validation, and testing. And as you can see on your screen, the objective of each data set is written right there. The training one is used to actually train the algorithm. The validation data set, then you actually validate the results, and whatever shortcomings are there in the algorithm, you then fine tune it, reiterate it, and run it again. And the testing data set is actually used to test the effectiveness or the accuracy of the algorithm which you have set. Now, once again, this is a very simplified version of what I'm telling you, and if you want me to actually bring in a live example or bring in some basic aspects of machine learning or a live exercise, I'd love to do that in a separate course. You can write down in the comments if you want me to do so. And once again, I want to tell you this video is a bit more longer than the others because we are actually going through an entirely different topic, which is machine learning. So please bear with me. Here's a very simplistic example once again. So as you can see, there are two different data sets, and many a times I get these questions even from my students that why do we need a machine to predict certain data, right? And why can't we do it ourselves? A very simple question is this. On the left is the data set which has numbers not in decimals, right? And predicting one number to the other is it's simpler. So if we see the first four brackets, then I think you can predict what's going to come next in the place of the question mark next to the 30, right? So the answer to that would be 60. I'm sure most of you were able to guess it. But if we come to the data set 2, once again, if you look at the first four data sets, and would you be able to predict what comes in the place of the question mark? If you are, well, you are a genius, congratulations, and I don't think you need machines at all to assist you. But if you're not able to do it, or if it's taking you a lot of time to do it, that is why machines are so important, because they are able to see patterns, they are able to predict patterns which we are oblivious to. Right. So now we are entering into, which I hope is the more interesting part of this session, is actually a practical machine building exercise. Now, once again, don't worry, there will be no coding here. We will not be actually writing any code or doing stuff like that. I just want to give you a very brief idea of how machine learning works, and be happy because we are just talking about pizzas. So it's a Friday night. You order a pizza from a local store called Joey's. The pizza guy says it's gonna reach within 30 minutes, right? 30 minutes or free. That's that's been a very famous slogan. Fine, it's a Friday evening, you ordered pizza, you're happy, it's reaching you in 30 minutes. The next thing you know, your girlfriend or your boyfriend calls you up and she says, can you ask, can she come over to your place? But what that means is you actually have to go and pick up the person. Now, if you go and pick them up, now they live around 15 to 20 minutes away, so that means it's going to take you at least 30 to 40 minutes for the to and fro journey. Your pizza is going to be here in 30 minutes, so when they come, you won't be here. And that brings a lot of thinking and tension. Why? Because if you wait that long for the pizza, it's going to get cold, because you're going to go pick up your girlfriend, you're going to come back, the pizza is going to be here for at least 10-15 minutes. You don't want that. Apart from that, if you pick up your girlfriend after eating the pizza, you are also going to miss your football match, and your partner is not going to be happy as well. So it's a dilemma, right? And yes, I know there are not many football matches on Friday, but I don't know why I picked Friday, so just forgive me on that one. Anyways, this is the scenario. So you've ordered pizza, you have to pick between pizza, girlfriend, football match, so many things, right? So how can a machine help in this case? So the first thing we need to understand is what are the variables we need to take into consideration. Now, once again, variable is any aspect or any factor which can affect the outcome of a situation. So some of the variables in this situation are the time taken to actually deliver the pizza, the time taken to come back from your partner's place, the number of people who might be ordering the pizza from the same place, the day of the week on which you are ordering the pizza, and the navigation ability of the delivery guy. So how well are they on a two-wheeler, for example. Not only that, the weather conditions outside. So if it's actually rainy or snowy, it might take the pizza guy or the delivery guy girl to longer, to reach your place, and then the entire math might fall. So what do? We apply something known as statistical modeling. Now, once again, don't worry, I'm not trying to scare you with some mathematical terms here, but it's essential to understand that machine learning is deeply linked with statistical modeling. Okay, so all we have to do is take certain assumptions. Now, assume that you have ordered pizza 8 times before today, right? It's a regular place where you order from, and you have ordered, say, 8 times before today. The delivery on 4 occasions before today was more than 30 minutes. So that means 50% of the time when you ordered, your pizza actually didn't reach you in 30 minutes. Also, you decide that you will only make a decision. What decision? Whether you go pick up your girlfriend or whether you wait for the pizza to come. You will only do it when you're 70% sure of either outcome, right? Right now we are not, because it's only 50% of the time when the pizza got late, etc. Now, the factor which we have to consider here is frequency. How many times was the pizza late, and on what days as well, right? That's really important. But the problem is that machine learning needs at least two factors. So we're just talking about how many occasions the pizza was late, but we need to take into consideration one more variable before we can actually feed it to a machine. So to solve that, let us look at some more variables. And once again, the basic 101 of statistics is that dependent variable is always the outcome, and the independent variable is something which affects the dependent variable. So in our situation, the DV, or the dependent variable, is whether our pizza will be significantly late or not, right? Everything depends on the pizza right now. And when we talk about the independent variable, there are multiple. As I already told you before, the capabilities of the pizza person, how many people have ordered, etc., etc. But let's take into consideration the day of the week, because the demand for pizza is not the same every day. Friday being the start of the weekend, and there are a lot of offers, mostly on pizzas. It might take longer. So imagine that every time your pizza was late, it was a Monday. Okay, why would that be? There's a possibility that they have lesser delivery boys on that day because demand is low, right? Everyone has been busy over the weekend and then they give an off. So, based on that, can you say that it will be late on other days as well? I mean, it's a difficult task because you ordered 8 times. Out of those 8 times, 4 times the pizza was late, but every time it was late, it was only on a Monday. So, will that also be the case for Friday? And you are only going to take a decision when you're 70% sure of a situation. So, let me try to make it a bit simple for you. The first question which we're going to take into consideration is today a Monday night. My apologies, it should be is it, not is. So if it's a Monday night, yes, will the delivery be late? The probability is yes and no. 70% of the time on a Monday it will be late, 25% it won't be. But today is a Friday, so we'll say no, it's not a Monday. Then will the delivery be late? There's a probability of it getting late is 25%. The probability of it reaching in time is 75%. Now, 75% is above your threshold for a decision. If you remember, we said that we're only going to take a decision if we are 70% sure whether the pizza will reach on time or not. In this situation, hopefully it will reach. So we are going to take that chance and we are going to go pick up your partner first and then come back, or whatever your decision is. But one thing we can be sure of is that the pizza is going to reach your place within 30 minutes. Now, once again, I want to tell you this was a very basic example of a machine learning, right? And we did not even take into consideration multiple variables. But when we actually work on a data set, you will always see there are at least 5 to 6 independent variables affecting a dependent variable, and then the machine has to make a prediction based on those. A very simple example is what affects a student's performance in school, right? There are so many factors, your health, the school which you go to, the kind of learning which you're getting, how many hours are you spending studying, kind of diet you are taking, how much sleep you're getting, what is your routine, etc. Now, in every situation, what we need to do is we need to quantify these factors. Okay, what does this mean? Basically, whenever we say that a person is intelligent, a person is a genius, how do we measure it? We have a scale called the intelligence quotient scale, right? So we need that is so basically that means we are able to quantify how to measure if a person is smart or not. Similarly, if we say that person is going fast, right? So we can measure that speed in kilometers per hour or miles per hour. Once again, that means we are able to quantify the measurement. So every time we want to measure something from an IV to a DV, we need to quantify the measurements. Now, I know it's a bit confusing, and I'm going to stop right here. This is actually the end of our very short course on AI for beginners, and the entire reason for this last session was to just give you a sneak peek into machine learning. I would love to, as I've already said, I'd love to float another course on machine learning if you are interested. I hope you had a good time. I hope you learned some new things in this course, and please like and subscribe my channel if you want more videos, more notifications. I will be coming up with a few new courses on sports marketing management, time management, marketing skills, etc. Well, that's all for today and this course. Thank you so much for watching. Have a great day.